Hello everyone, and welcome to today's webinar at Hydrosoft. We are going to be covering the topic of how to set up dynamic controllers in a GPS-X model of a wastewater treatment plant today. We're going to focus specifically on how to configure a mixed liquor controller and an SRT controller. And so I won't be going into a lot of detail about how PID loops work, but more so focusing on how to set them up in the software. And we're going to be running a couple of live desktop demonstrations, and I've got lots of slides to show to sort of explain how everything fits together in our software. So, my name is Spencer Snolling. I'm the VP of Product Development here at Hydrosoft, and I work a lot with GPS-X and its development and its application, and I'm glad that you can join us today. If you've not been part of one of our webinars in the past, these are things that we do on a sort of a roughly monthly basis where we look at different aspects of our products. We look at different software features, sensitivity analysis, and so on. And then some months we spend time focusing on the model itself, maybe one particular unit process or one particular aspect of wastewater engineering and how models can apply to that. So that's where we are today. We're looking at process control, specifically mixed liquor and SRT control, and how that can be carried out in GPS-X. So this is the agenda for this afternoon. As you know, we try to keep it to around 30 minutes or so. If you have any questions along the way, things that pop up to your mind, you can type those into the GoToWebinar questions box on your GoToWebinar dashboard. Usually the way we do it is that you can go ahead and type those in as I'm speaking over the next half hour, and then when we get to the end, I'll wind things up, and then I'll hang around for another 5-10 minutes and answer as many of those questions as we can in a short period of time. So my plan is to just give you a little bit of an introduction to doing dynamic control in GPS-X. I'll review the process control options that we have available in the software. Process control is a big part of doing dynamic modeling, and it's really quite an extensive and detailed area. We actually offer sort of a whole half-day workshop on that. So I won't be able to go into everything that we can do here in the next 30 minutes, but I will sort of put it all in context. Then we'll talk about how to set up a PID loop for controlling mixed liquor, and then we'll go into how to define an SRT and then apply a controller to that as well. And then I'll wind up with a few things that are sort of typical tips and things that you should keep in mind when you're putting your model and your controller together, and how to troubleshoot when you have any problems. And then we'll answer those questions that you've typed into the box when we get to the end. So just to set the context here, we have lots and lots of different ways to put dynamic process controllers into a wastewater treatment plant model. So we actually have many different built-in controller types here. So in the very bottom panel of your unit process table, you'll find a process control group, and we have PID controllers, on-off controllers, and so on. These are all things that you can drag and drop onto your drawing board with your wastewater treatment plant. They do different things. The timer and scheduler ones are there to sort of make changes to the process itself, turning pumps on and off or controlling valves and do whatever. These are things that are going to be done on a schedule. So they don't really monitor any process. They just happen as time passes on a certain schedule. Those are all super useful, and I use them a lot in my work. They're there for you to investigate. We also have an on-off or a high-low controller where you set upper and lower bounds that you want to apply to a process. So you could say, I want you to keep my mixed liquor within this high level and low level, and then you set some pump settings for that. But really what we're going to be talking about today is traditional PID dynamic control, where you have a set point that you want to drive that process to. So we're going to talk about how to configure that for a mixed liquor controller, and those are all found at various points throughout the various menus in GPS-X. Anytime that you want to put down any of those other ones that I've just mentioned, you can just drag and drop them on. I'll refer you to our technical reference guide in GPS-X. You can use as many of those things in concert together as long as you're not trying to use two of them to control the same parameter, and that can all be there and built into your model. Okay, now focusing specifically on PID control for mixed liquor, any of the tanks and the unit process objects like this clarifier here that have this symbol on it, this PID, sorry, this pump symbol on that object, that is going to tell you that there very likely is going to be a PID controller already built into the menu for you. So you don't have to drag one of those other objects onto the screen. So any place you see that on the object when you're laying out your drawing board and so on, you can open up the operational input parameters menu, and this is where you set the pump flow rates and so on. And in a lot of cases, what you'll see is right next to the entry for how much I want to set for a particular controller, I can actually see an on-off button for that PID control loop. Now, by default, they will always be set off, but you can actually access this more button right here. When you click on that, that is going to open up this large menu with all of the details of setting up that PID control loop. And we're going to go through this in detail about what all of these things mean. But basically, this is how you define a PID control loop. Everything is already built in there. It's already part of the system, but you have to specify what is the control variable that we're trying to do and provide some tuning and some other information as well. So you'll note that once you kind of are looking at that, you'll see here that if I have the controller off, so this is the off button, you'll notice that I can just set that pump flow directly. I can type in whatever number of meters cubed per day I want to pump out of this particular unit. If I turn on the controller, now the control loop is going to be setting that pump flow rate. So you'll notice we've now deactivated that menu, and then you set the set point for that particular control variable. Now, because we don't know what it is ahead of time that you may want to be setting that that control variable for. Like, in other words, you could try to say, I'm going to use this pump to control mixed liquor or SRT or sludge blanket height. It could be anything. We don't have any sort of feeling for what the value of this set point should be. So you'll notice very often it just says 1. You can then set it to an appropriate value. Then you would hit the more button over here, and then it's going to come up with what is actually the main thing that you need to focus on when you set up your PID control loop. Now, I'm just going to quickly run through what all of these parameters mean, and then we'll do a live desktop demonstration where we put that together. So first of all, starting at the top of that menu, are some settings for the PID control loop itself. So what we mean here is that there's different types of PID control loops, and in fact, PID is standing for proportional, integral, and derivative, and you can even use subsets of those. You can make it just a proportional controller if you wanted to. Now, I won't dwell on this because most of the time I leave the PID all just at the default settings. The next control variable specification, this is one of the key things that you will have to do. You will have to tell GPS-X what is the thing that I'm trying to control. So in this case, it's talking about mixed liquor. So we have to go and find what the name of the variable is for the mixed liquor and enter it into this particular field in the menu. The next item is the controller sampling time. So that means how frequently do you want this controller to take an action? So you may want to do that once an hour or once every 15 minutes or once a minute. It really depends on the type of control system that would exist out there in reality or what you're trying to do with your particular control loop that you're setting up. The next 4 parameters are the key tuning parameters that you are going to have to adjust. And the settings that you require here, the tuning that is required to do a good job, is a function of many, many different things. This default set that we have here is very generic. It's probably 99% chance you're going to have to change it away from these settings in order to be appropriate for the particular unit that you're using. So it's a function of the size, often the size of the plant that you have and the nature of the time scale of the system that you're controlling and so on. So we'll go through how to determine what those things are. The next 3 are really just settings that are there to help control and sort of limit the controller and keep it in the bounds of something that's realistic and provide a little bit of safety features on it. To be frankly honest, this is not something I touch on a regular basis, so we're just going to leave that alone for now. But this is a very important aspect. The minimum and maximum bounds on the manipulated variable. In this case, it's going to be on the pump. So this is the minimum value and the maximum value that the controller will be allowed to move to. So right now it's set to 0 and 100 meters cubed per day. That should be quite fine for doing the type of wastage scenario that we're going to have for the default plant that I'm going to show you. But you may find that those are something that you have to go back and adjust. And lastly, this is the control tuning feature that we have built into GPS-X. This is something that you can use by running some simulations to determine a good set of tuning constants. What I'll do is I'll come back and I'll talk about it at the very end of the webinar. So when you're determining what types of tuning constants that you want to use, it's important to sort of understand what the various elements are in this grouping. So the two most important ones that you need to deal with are the gain and the integral time. So these are ways that you adjust the aggressiveness of your controller. What you want is something that is going to make actions fairly quickly and push your process to that set point. So if we're saying we want to have a mixed liquor of 2,500 milligrams per liter, you want it to have that pump make a change and get there as reasonably quickly as it can, not overshoot it by too much, but keep it in the right neighborhood. There's no perfect controllers that are always going to keep everything right on the set point all the time. But what you want something is always coming back to the set point and not doing it in an unrealistic kind of way. You don't want to be too aggressive because then it's going to cause a lot of changes to your pump. And that might not be even realistic at all for the type of system that you have out there in reality. So the key things to keep in mind when I'm starting to put together my controller and I'm going to run it is that if I have to tune that PID control loop, increasing the gain will make my controller more aggressive. So it's just like volume. You turn it up, you're just going to get more signal. The integral time is the opposite of that. If I increase the integral time, that will make my controller less aggressive. And integral time is a little bit more about how long it takes things to get there. And gain is more or less driving it, the slope of driving it to that correct point, to that set point. So by combining and making adjustments to both of these parameters, you can usually find a good setting that will get you there, it'll keep you there, and do it in a sort of reasonably safe way. The last thing that was in that grouping that I showed you earlier was what we call the controller effect variable. And this is an on-off. Essentially, really what this is it just tells the controller which direction do I need to go. So you basically just either have this set on or off. And it is asking which way do the process and the control variable work. So when you have things that work together in the same direction, so for example, a DO controller, if I increase the airflow, that increases the DO. If they act together in the same direction, then you want to set this parameter to on. If they act in the opposite direction, then you want to set that controller to off. By this, I mean this example that we're going to be working on today. If I increase my wastage rate, that will decrease my mixed liquor. So the action and the response go in different directions. Therefore, this parameter needs to be off. What it basically boils down to is in the PID loop, it puts a plus or a minus on the beginning of the equation. It sets the sign, and then the controller will act in the right direction. Okay, so that's enough talking for now. Let's get down to actually doing some simulation. So I have put together this very simple, straightforward plant just to show you how to set up a mixed liquor controller and give you a feeling for what the menus look like and so on. So just to set the stage here, we're modeling just the activated sludge portion of this particular plant. We have one completely mixed aeration basin with a secondary clarifier and a recycle. And this is actually a very small plant. It's the default size that we set up. This is more or less the example that you will find when you do our tutorials in GPS-X. So, and in this case, what we're going to try and do is we're going to control the mixed liquor in this bioreactor here by changing and letting the PID control loop control the wastage here. So it's as if this was a variable speed drive that could be turned up or down as needed, as frequently as needed by the PID control loop. And so the other thing I'll mention too, I've set this up so that there is a diurnal pattern on the primary effluent flow that's coming into this system. So there's some dynamics happening here. The flow is going to be going up and down, and we're going to run 3 or 4 days of simulation. So you'll see a few days worth of dynamics happening as we go along. Okay, so the first thing we need to do is to open up the menu and find all the settings for the controller. So you do that by right-clicking on this object. So this is the point where we want to apply the PID control loop, is on that pump. So we're going to right-click, go to the input parameters menu, go to the operational menu. The PID controllers are almost always found in the operational menu. And we will go down here and we see this pump flow is for where the waste activated sludge is. It's the same as that label right there. And we can see right now that this is the default settings here. It's got a flow rate, it's a constant over time, and this controller is undefined and it is currently turned off. So what we want to do is set this up so that it can be monitoring what the mixed liquor is in this tank. So first of all, you have to turn it on to get access to all of the parameters. So now we can see here, it's going to ignore this number and it's going to be controlling it instead. And we want to do the set point. So let's start out by doing this at 2,500 milligrams per liter as our mixed liquor concentration that we're shooting for. And I'm going to click on this More button, and now it's going to bring up that other second menu that I showed you earlier. So I'm going to leave these two settings at the top the same. We're just using a standard default PID control system. And now I need to find the name of this control variable. So I know that I want to do the mixed liquor. So I know that I can find that variable. What you do is you do the same process you would do to find a variable to plot it on a graph when you're in simulation mode. So you right-click on that tank, go to Output Variables, go to Composite Variables. This is where you would find the mixed liquor concentration. And we can see here, this is the thing that we're after. The absolute easiest way to find that is just right-click on those words, and it says copy cryptic name to the clipboard. That is the name that goes in this particular spot. So let's grab that. That's now on our clipboard, so I can come over here, Control V, and paste that value in. So for those who are familiar with doing customization with GPS-X or using Axle to set parameters, this is the cryptic variable name exactly the same way that you would use when you were writing your own custom code. So these are all the sort of cryptic. By cryptic, we mean the actual name of the variable as it appears in our underlying code that is the mathematical engine of the model. So XAER is the name of the mixed liquor in this particular tank. Okay, moving on, setting the controller sampling time. So I'm going to leave it at 5 minutes. I think that's probably a pretty good value. That's probably maybe a little more aggressive than might be required. I mean, growing biosolids is a relatively slow process. So, you know, I could have put 15 and it would have worked too, but let's leave it at 5 for now. The proportional gain and integral time, I'm going to leave at the default just so that I can show you what it looks like when we make changes to those. But I do have to come in and set this controller effect parameter. So in that last slide that I showed you where I was talking about whether this should be on or off, we have to ask ourselves, does the controller action and the process variable move in the same direction or in opposite directions? And since this is an opposite one, increasing the pump flow rate decreases the mixed liquor, then this should be off. So we have that off, and I'm going to leave all the rest of this at the default values. So let's accept that, and we'll accept this, and we're going to go over to simulation mode, and now it's going to build our model for us with the default, with this PID controller already turned on. So I've already set up a few graphs just to keep things moving along quickly. I've taken some of the parameters that are typical things that we may want to play around with, and I've put them up here. We can see the integral time and the gain, these tuning parameters that we want to adjust. Here's our influent flow, and this other parameter is the set point itself, so we can even see how well we do in that simulation. So I'm going to run 4 days dynamic simulation right now, and so we're going to run that, and we're going to take a look at what's going on in this graph. So first of all, take a look at this blue line here and the black line. The blue line is the set point that we set earlier, that 2,500 milligrams per liter, and the black is the actual mixed liquor in that reactor. And we can see here that's actually doing a really good job. It's right on top of that line, so it's actually being well controlled. However, I'm sure you've noticed the red line. That is the actual flow rate that the PID control loop is setting for that particular pump. And it is, needless to say, all over the place. So this is actually a very poorly tuned controller, which is not surprising because we didn't do any tuning yet. So you can see what is happening here is that the controller is saying, well, we need lots of wastage, and then, oh, now that's too much, so I'm going to go down and I'm going to go up. So the controller is acting in the correct direction, but it's just way, way, way too aggressive. In some points, it's actually turning all the wastage all the way off here. So what that means is we need to reduce the aggressiveness of this PID control loop. So we're going to tune this controller by making it less aggressive. And that is done by increasing the integral time. So as I mentioned earlier, the integral time is the one where it acts in the opposite direction. So I'm going to increase that from 0.01 to 0.1. When I'm doing a rough PID loop controlling exercise, I often move things up and down by an order of magnitude very quickly, just to make sure I got something in the right neighborhood, and then we'll go from there. Okay, so I'm going to run that again. Well, okay, now it's not nearly as aggressive, but actually it's still doing a good job of keeping the mixed liquor in the place that it is supposed to be. But that's still quite widely varying values. That's probably still too aggressive. So what I'm going to do is also reduce the gain here by an order of magnitude. That's essentially going to change the slope of this. It basically means the amount of response you get out of your controller per unit change in the control variable that you're observing. So in this case now, by dialing down the integral time, dialing up the integral time and dialing down the gain, we've now achieved something that is a reasonable level of control. Now, mixed liquor doesn't really change all that fast. It's unless you're blowing all the solids out of your plant, it's something that is not going to be changing on the order of minutes. It's something that happens over hours or days. So, so this is not too surprising. That is probably the kind of place that we want to be with our controller. So now we have a mixed liquor controller in place. If I were to change to a different influent flow, if I'm going to do this dynamically here, just push this up slowly while the simulation is happening, you can see that it's doing a pretty good job of keeping that mixed liquor, at 2500 as we asked for. Now you'll notice, of course, it's wasting a lot more solids than it did in the previous run, because now with higher loading to the plant, we have more solids to waste. So that's an example of setting up a mixed liquor PID control loop, tuning it, and then playing around with it a little bit and seeing how that reacts. So that's basically what a PID control setup works like in GPS-X. So as I mentioned, that was built into here where you saw that unit, so that's already there. If, as I mentioned before, you want to set up a PID control loop, but you don't have that controller already present on the menu for a particular parameter that you want, you can actually grab this PID controller here and just drop one of these on the board and then install both the manipulated variable and the control variable and just do all that tuning and everything just like we did now. And those are sort of free-form ones that you can add as required. Okay, back to the slides. Okay, so now moving on from mixed liquor to SRT. So SRT, just to remind everyone, in this case I'm talking about sludge retention time, or solids retention time as some people refer to it. It's the sludge age. It's the average time that a unit of the biomass spends in that system. How long does it sit there and grow before it gets wasted away or goes out in the effluent? So as you know, of course, this is a really key, very, very useful parameter in looking at wastewater treatment plant design and operation. It tells us how long that biomass is going to be there growing, and we know that certain aspects require a certain length of time in order to be able to do their job. So we know that we're going to need 5 days of SRT in order to nitrify at a wastewater treatment plant. So, but SRT is defined differently. It doesn't have a hard, rigorous definition the way some other parameters do in wastewater engineering. So in a lot of cases, some people want to sort of tailor the definition of the SRT for a particular process problem that they're looking at. So for this reason, we don't have an SRT already defined for you in the software. We ask you to define what the SRT is in your mind, and then we add that equation to everything else that we compile in the model. And then now you have a chance to put a controller on it and do other things with it. So let's just start with that first. How do we define the SRT of a particular wastewater treatment plant? And actually, I've got SRTs here because you can actually do more than one of them. The SRT basically is determined generally by looking at the mass of the solids in your system and then dividing by the rate of loss of those solids. So you're dividing the mass by mass over time, and that gives you time. So it's the residence time of solids in that system. But there are a lot of questions around, okay, how do we define that mass of solids? Are we talking about including all of the bioreactors in our tank or in our system? Normally that is the case, but maybe not always. And then the really big question is, do we include the solids that are in the clarifier? I know a lot of people who don't because they're saying, well, when they're in the clarifier, they're not really biologically active. It totally depends on whatever is your favorite way of doing it. So you can do that or not, depending on what you like. Same thing on the lower side, on the denominator of this equation, do I include the wasted solids? I mean, almost always you're going to include that in the rate of loss of solids, but there's a question of whether do I include the loss of solids through the effluent as well? And maybe that's important to you, or maybe it isn't. So anyway, you need to sort of define your equation as you see fit in GPS-X. So our define function allows you to define multiple SRTs, and you can include or exclude tanks and flows as desired. And all of that is done through the GPS-X define button, which is this one across the top. It's about in the middle, and it is this sort of F as a function of X button here. It's actually a menu. If you pull it down and select solids retention time at the bottom, that will bring up the SRT definition menu. And there's a lot of words here describing and giving you the instructions that you need. I realize this screenshot here is a little tiny, but we'll move on to doing a live demonstration. But in general, what happens is you click on plus here, which means I want to add a new SRT definition, and then you move that menu out of the way and you start clicking on objects in your layout as you have it drawn on the drawing board. And when you're over top of a tank that could be added to the equation, you'll notice there's a little plus sign with the hand there. So every time you click on a tank, it will add it as a term in the equation. And every time you click on a connection point, it will add that as a term on the mass flow side. It's pretty straightforward. Once you're all done, close the menu, and then now we've derived a new equation for SRT that you can then plot. So when you're over in simulation mode, you can just go and grab that same menu again and drag it and put it on a graph and plot it just like any other variable that you would in GPS-X. Okay. The reason we allow for multiple SRT definitions is that quite often it's useful in BNR systems and biological nutrient removal systems that are doing nitrification and denitrification and biological phosphorus removal to be able to define not only the total SRT of the whole system, but also just the aerobic SRT, or maybe just the anoxic SRT. And sometimes you may be building a plant that is physically one wastewater treatment plant, but it may have multiple trains that differ from each other. So you may want to define two different SRTs, one for each side of your plant. So the way that you do that is each time you build a new one, you give it its own unique name. And when you click on a reactor that has more than one unit in it, so at one of our plug flow tanks, for example, it'll pop up this little menu here, and you can select or deselect which reactors within that plug flow tank that you want to include. And that's usually what happens in a BNR system where I have some anoxic tanks at the front, and so I don't want to include them in my aerobic SRT definition, so we'll just uncheck those. Okay, so let's go and define an SRT. So I'm going to pop over to another layout. It's more or less exactly the same thing that I just showed you. Okay, so same thing again. We have exactly the same setup that I had before. Now, what I'm going to do is going to go to this define button up here. And I'm going to pull that menu down, pop up that SRT menu here. And if you follow along these instructions here, it asks you to, first of all, click on creating a new SRT variable. Now, in this particular case, we're just going to do simple total SRT of the whole system. So I'm going to call it SRT total. I accept that. And then now as I move around the plant here, I can start clicking on the objects that I want to appear in the equation. So I want to, for the mass part, the upper half of the equation, I want to include just the solids from the aeration basin. So I do that. Now AER, which is the label of this tank, appears in my mass equation. And I only want to add the was here. So if I move my cursor around here until it's that little arrow pointing to the right, we can see a plus sign. That means I can add that to this equation here. So now I'm saying I'm taking the mass of solids in the bioreactor divided by the amount mass flow of solids that we are wasting. So let's close that window. Let's see that layout, and then we're going to come over to simulation mode, and now it's rebuilding this model with that new equation that is there. And so I'm going to go back to a very similar menu, graph that I have created here to show you the behavior of the SRT. Now, I have to go back to that same menu to get the variable and drag it onto this graph, just as you would from any of the menus that we have in GPS-X. So I'm going to drag SRT total here, drop it on that graph, get rid of that. Now, you will have noticed we actually added two variables when we did that. The regular solids retention time, as we would have defined it, and also the dynamic solids retention time. I'm going to open up the menu here, the properties menu, so you can see that without having to lean to the left. So this dynamic solids retention time is actually defined slightly differently than a regular sort of instantaneous calculation like was on my slide. I won't go into a lot of details about it. Just refer you to, just check our tech ref guide and we can talk about how that is. You're sort of integrating solids over time dynamically, and so, but won't deal with that complexity today. So I click there to remove that one. We're really only going to deal with solids retention time. And while we're in here adjusting the scale of this graph, I don't need to plot it up to 1,000 days. Let's actually just plot it to 50 days. Now I've got two things that are black, so I got to change this color here. Let's make that blue. Okay, so now we're ready to go. So I am now going to run again a 4-day simulation. We've got some dynamics happening. And now we can see what the system looks like when we run it, again, with those daily diurnal patterns. So first of all, there's no control happening on the system. We're not controlling anything yet. We're just running with, in red here, a constant wastage rate of 40 meters cubed per day. We can see the mixed liquors kind of going up and down. We can see that this SRT that we're calculating is also going up and down as the mass of solids in the system is changing. And actually, because of those dynamics, the actual mass flow itself is changing too. Even though this is a flat line here, the concentrations in the clarifier are changing a little bit as you go back and forth. So that's why this number is bumping up and down. But anyway, let's take a look at that. Well, that's around, it spends most of its time here around 12 or 13 days of SRT. So that's lots of time, lots of SRT to nitrify at this particular plant. Okay, so that's an uncontrolled system. So let's go back to the slides and talk a little bit about putting a controller on that. So now, the SRT can be dynamically controlled by adjusting the wastage flow rate, just like you can do for mixed liquor. It's very much the same thing. You're just monitoring a different measurement. In this case, instead of a concentration of solids, we're going to be looking at that residence time of the tank. So the good news is that GPS-X actually has a predefined SRT controller that's built into that menu. And this is the one that I recommend that you use. It's the most straightforward one and easy to set up. So it does basically instantaneous calculations of what the wastage rate should be. So it's actually just basically a simple mass balance. We actually know all of the terms that is in the equation that I was showing you earlier, except we just plug in, we want a certain SRT, and we just solve for the wastage rate. So that's what we're doing in that case. So the good thing is that there's no tuning required to run that particular controller. So just to highlight where you're going to find that, if you go to the place where we were defining that equation and when we were clicking on the different objects, there's a little checkbox here, estimate WAS, waste activated sludge rate. by using a set SRT value. So you have to set these particular parameters here. You have to tell it which connection point to use and what the set point is and so on. And then that is available for you to set that up in your system. So let's go back to our desktop demonstration for the last time here and do that very thing. Okay, so back to modeling mode. I'm going to go to that SRT menu. And here's our definition that we just did before. I'm going to click on the estimate was using SRT. So here's all of those settings. Right now, this is a very simple layout. So this little pull-down menu normally would have probably several different pumps in it. Right now, GPS-X knows this is pretty much the only place that you would typically want to waste solids from. So it puts that one option there for you. Here's the set point. Here's that minimum and maximum number that I talked about earlier. So that's going to apply to this pump flow rate. These maximums are fine. So I'm just going to leave that turned on. Save that and run the simulation. So it's going to rebuild it with the controller built on as our default. And then we'll run another dynamic simulation here. Okay, so in this case, again, 4 days dynamic simulation. And instead of seeing before the red line was flat here at 40 meters cubed per day, now we're seeing that the SRT, the blue line, is completely flat because the wastage is being controlled in order to get this flat controller. So I could change to a different SRT set point. By the way, you noticed here now it's wasting more because we're actually getting it down to a shorter SRT. Before it was at 12 or 13 days. Right here, we're telling it waste whatever is required to make it 10 days SRT. And you can see obviously that we waste more in order to get a shorter SRT. So, but let's say for argument's sake, let's keep it at 15 and run that again. And we can see here that it's at 15. Our mixed liquor is now much higher than it was because we're holding back a lot of solids in the system in order to keep a very high SRT. Okay, so that's how you do SRT control. Now, there's a lot of other things that you could do as well. I mentioned earlier on, we have all those other different kinds of controllers. They can all be applied to your newly defined SRT variable at any point as well. So there's lots of different things you can do in GPS-X with respect to control. So I realize I'm going on a bit longer than normal here, so I'll wind it up by giving you a few tips on setting up and tuning your controller. So the PID loops are pretty straightforward to set up. A few things you need to keep in mind. One of them is getting the correct cryptic variable name for your control variable. So make sure you do the methodology that I showed you earlier. Find the variable that you want to plot and just copy that by right-clicking on those words. And you have to make sure that you have your control effect on the control variable set in the correct direction. Otherwise, your controller will move actually in the opposite direction that it should. And usually that's a really obvious thing. When you run your simulation, your controller won't work at all. So it's important also to set realistic values for the minimum and maximum of that pump. So those variables that are down at the bottom of the menu here are important. Otherwise the PID control loop is essentially just a blind calculation. It's going to turn up the pump as much as it wants to do it. So it might take it to a situation where it is at a completely unreasonable pump rate that you would never see in reality. So. Just a couple other thoughts. I've had people ask about how to do things in the past. Is it possible to set the controller on a moving average of the SRT rather than the instantaneous value of the SRT, which might change more quickly? And the answer is absolutely. You can actually create a moving average of any variable in GPS-X by going back to that same menu that I showed you earlier where we were selecting the retention time menu. And instead of selecting retention time, select moving average. You will have to have defined your SRT first and then go back into this menu, go to moving average, select the define variables menu, and then you can define a moving average of your SRT, and then you can build a controller on that. As always, poor tuning can lead to really undesirable results. This is a couple of screenshots from our workshop that we do on PID control, and you can see there's lots of different ways it can be tuned, be too aggressive or not aggressive enough. It takes a very long time to get to the set point. And lastly, when you're troubleshooting, sometimes you'll find that no matter what you think you've done correctly, it still won't do any control, like it won't do anything at all. often it might seem obvious, but is the controller on? Did you accidentally at some point turn off that on-off button that you had to access the menu with? Seems obvious, but I've made that mistake myself, accidentally turned that off. Is the sampling interval appropriate? Like if you have a very long sampling interval, like, the controller only took an action once a day or something, then it might seem like that it's pretty well off. That's also a possibility. Or is your pump or your whatever manipulated variable you're using, is that at the minimum or maximum? Is it like bound? It wants to keep moving and making a larger number, but it can't because you've got it bound and not allowing it to go past that maximum, in which case it then doesn't do anything. It just stays at the maximum. So it may seem like it's not doing anything. And lastly, this is just a GPS-X software issue. Just a way that we put all of our information together. It's always good practice to not have the manipulated variable that you are trying to control with the PID loop also up as an interactive slider. It's just particularly true when you're using customized variables that you've created or written some control for. Written some code for. If you have a variable up on a slider, then the GPS-X will want to set it to that value, but your pump controller might want to set it to a different value, and the two things will fight with each other. So just to make sure that if you're using a PID controller, don't also have that same variable up on a slider too. So a few final thoughts. We have that auto tuning functionality that I mentioned earlier. It's at the very bottom of the PID menu. Basically what it does is you run the system once with this tuning functionality on, but the controller off. And this monitors the response of the control variable to a small change and then sees, sort of how drastic that system responds to a small change. And then it estimates tuning constants from that. So that's kind of handy, works most of the time. It is possible to use cascading controllers where you use one controller to set the set point of another controller. And you can do that as many in series as you like. And in fact, this is the basis of ammonia-based aeration control. And we have an entire webinar just on that. So if you go to our YouTube channel and go into the section on webinars, you can find our ammonia-based aeration control. And we do this exact thing. And it'll show you in that video how to set up cascading controllers. But if this is new to you, setting up a GPS-X PID controller, then I suggest you take a look at tutorial 5. We also have a video of that on our YouTube channel where you can see the step-by-step processes, more or less what I just was doing here in this webinar, but it goes into quite a bit more detail and it shows different ways to set up different controllers, and including the auto-tuning. So, as we know, MLSS and SRT are important process parameters frequently used under PID control, and you can set all sorts of different interesting control systems around to investigate that behavior. And because GPS-X is kind of a very open source type of system, you can write whatever kinds of control systems that you want. And there's a lot of opportunity via the things that we already have built into the menus, and also things that you can create from scratch on your own.